This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. How are you?
Good morning, Peter. How are you? We spent 3 days in the beautiful Black Forest at SIG last week. And what is your opinion?
Yeah, it was amazing. Yeah, we called it Black Forest 2, right?
Black Forest 2, right? Yep.
Yeah, right. We have been in the Black Forest. When was that? 2 years ago, maybe, with Arborg?
I think at Arborg, 2 years ago, yeah.
Right, yeah. And it was only when I came back, and it just by real coincidence, I had been very close to where we were. SIG Sensor Solutions, they're in Waldkirch, and that's not too far away from where the Unicorn Black Forest Labs is based as well, right?
Exactly.
Well, I mean, as we arrived, and there was a traffic jam, as I believe there always is in the direction of Basel. But you see these huge forests, which I guess that's what we call the Black Forest. Yeah, it was very impressive, very impressive. It was a great setup, a great environment. As always, 30 persons, 3 teams, no PowerPoint. And what did we say? Is this the 7th one that we did, maybe?
I think the 7th, yeah. Everything started in a monastery in Würzburg, yeah.
The monastery in Würzburg was the first one, yeah. So, yeah, it was great. This time we had, again, as I said, 3 themes. The first one was foundation model-based time series, or not the first, but it was one of the 3 use cases, as always, with Marco Huber. And the first one, just mentioned that as well, then with Sebastian Böck, colleague from NXAI. And then we had the great Jakub Tomczak, who flown in from San Francisco, our Gen AI, as we call popes. But if we use that word, we use it always in a very respectful sense and not in a religious way for you listeners that are religious. Yeah, it was great.
Yeah, it was a great honor that Jakub came from San Francisco. It's a long trip, right? From San Francisco to Waldkirch in the Black Forest. But you can hear more from Jakub in the main part. Let's move to the other session, because Andreas from Responsible Annotation, a company that employs people with autism, kicked off the whole event, and this was really impressive, right? The crowd was impressed by the work of Andreas and his team, and he's a really competitor to annotation services in India, Africa, or South America. And I think it's a great idea. It's a great niche in the whole AI field to work on this, right?
Explain the base idea, because people can maybe have a slight idea what this could be about, but maybe you want to share what the base idea is.
Yeah, sure. He and his team employ people with autism, and they have very special needs, but they are very qualified to annotate data, right? And in the past, it was like that: when you have autism or you are in the autism spectrum, you only can work in a workshop or something and do stupid stuff. And now, and that was this frame, from charity to taxpayer, make them not from charity to taxpayers, and that was a great idea, I think.
Yeah, it's really is amazing. Yeah, and I recall my personal first question being like, I mean, how does the community, how does the world experience? And by not sure that he is seeing the sweatshops in India and many other places as competition, because he's not trying to.
No, it really.
No, but the idea being, it's not like, if they do things for whatever 10 cents, he's not going to go at 9 cents, as you just said. He's looking at people who until now have been in workshops, and now they can become the taxpayer. It's almost like a weird, as if the organization say, okay, there's human beings who can pay taxes, but it's really for those people. And it's amazing. I think he started off saying, consider yourself, sit at your desktop, and that's where the first bouncing box comes in, and you're supposed to say, okay, this is a car, this is a giraffe, this is whatever this is. And that's very interesting, until 5 minutes or 10 minutes. And after half an hour, you think, oh, this is not easy. And that's, I understand, is what the people with autism have, this amazing capability, which is, different from other people who do not have autism. You could call them normal, but I think we don't do it like that these days.
Exactly.
And so it's almost like not like a USP. It's almost like a thing which sometimes makes it difficult for them to be amongst people that do not have this autism. It suddenly becomes a real advantage. That's how I understand it, right? It's amazing.
But it was interesting because you mentioned India and Africa, but he said that now research institutes can also hire him when it comes to annotation. And normally when you want to get European grants, for example, for a research topic, and he says now they have now an European option, right, to do that. And it's not an Indian option or an African option. So it's an option for them to hire now a European company. It's even easier to do that, to get European grants when you do it with a European company. And that's also one USP of his company, because he's the only one in Europe, right?
That's amazing. Yeah, and if there are, I assume he's the only one with this approach, with the workers being autistic. And if there are others, which I do not know, but I think he was saying not. But if there would come, then the additional advantage he would have is that he is including people which normally would not have a chance to receive, to work, and to become, as we said, a taxpayer, which means in a positive sense earning money for themselves. Yeah, that was an amazing start. So yeah, if
But it was funny because at the beginning he started his presentation. It's not a PowerPoint presentation, and he said, "I will tell you a story now," and everybody was surprised. What kind of story is coming now? And then he told the whole story of the idea to build first an NGO on this topic, then build a company. And I think after 10 minutes, everybody was in the story and was fascinated by the story.
Yeah, and he kept on talking. We then had to jump in at some point.
Exactly.
Because I think he would have continued for another 2 hours probably.
Yeah.
Yeah, very much, very, very impressive. If you, dear listener, have a job annotating, we are happy. Maybe we can make the link available to his company, or
Yeah, we can do that in the show notes.
yeah, contact Robert and myself if you want to use the services.
And you can do a little annotation test, right? I will also share. He established a test online. You can prove yourself if you are able to solve the annotation test.
Oh, really? That's interesting.
Yeah.
I'll try that myself.
Perfect.
That was the start of, yeah, right. And then then maybe we talk about the session with Sebastian.
Yeah.
We had Sebastian back before. This time was about foundation model based time series. Yeah, it's amazing. My interest was in comparing time series with the past. I had listened into the main part, which I believe you say we're going to have today. You did with Jakub. And what did he say? Time series are the thing of the future. I mean, another wonderful quote I think he has there.
We have to crack time series, I think.
Oh, there you go.
To go further, yeah.
Right, now we are cracking time series, and you're rather close to that. We talked a lot about it in the car back, actually. My takeaway from the session I had, and it was more general in this one, but also later on with in Jakub's session, is that where Sebastian confirms that and talking specifically in this case XLSTM based Tyrex needing 5 times less CPU. That is 5 times, and that is in the average or in the middle section, and that grows with growing context, I understand. And I just don't get it, right? I mean, I do not understand, and I'm so convinced that if one of the big tech, we know who the big tech is, if one of them at some point in time is going to announce a cooperation of using an XLSTM based, a Tyrex based, or whatever, maybe a hybrid architecture in combination with transformer. As I said in the past, Sam, you realize that you don't need to build 5 data centers, right? If you use the right technology, yeah, 1 data center is enough. And that was maybe a little bit in combination then with the session I sat in with Jakub talking about, because I was asking him directly, and he said he's not aware of, he's within the Meta environment, but of course he's close with everybody, and he knows all the developments. Not all, but he's in the scene, and he said he wasn't aware of. But he was suggesting a couple of things. Number one, people are lazy. We are lazy, he says. So if we researchers, if we have a solution, and he was referring to transformer, then we're lazy. We just take it. And maybe there is a little bit of this not invented here syndrome, at least within the valley. I'm not putting those words into Jacob. Those are my words I'm using. So there's a little bit of this, when we then later saw this post about, the Black Forest labs and all the other wonderful things happening around Freiburg, that's where, of course, and the people from the south of Germany or Europe are very proud. Is one of these hidden champions, like is SICK Sensor Solutions, only if you are in that business. So that was my main takeaway. And I was telling Sebastian, not Sebastian, the people at Annex AI around XLSTM, around Tyrex, as soon as one of the big tech is going to be using, then we may be seeing a little bit of a bubble burst, as everybody is talking about.
I don't know.
Because that's clear that you maybe do not need them, or just 1/5 or 1/6 or 1/10 of CPU that we're looking at for the complete world that we're in.
My session with Sebastian and the guys was very technical, and they discussed the architecture of foundation models. And at the end, still everyone was surprised at how the models, all time series foundation models, generalize. So this is a huge topic, and a huge topic for the industry to see that there are models you can use on machine 1, machine 2, machine 3, material 1, 2, 3, and the results are still impressive, right? One shot, zero shot, and without any training. And this is still impressive for the people in the industrial field, I would say, because since 15 years, we hear the story industrial AI is very complicated. It's still very complicated. But now you have models that can generalize so well. That's very impressive for them.
Right. If I just think back, and I would have loved to be able to use, and to be honest, the only thing that I have been aware of as I was actively involved as a project program manager, and at that time we were using the Bayes algorithms. They're called ARIMA, they're called sliding window, whatever they are, very much of statistics based, maybe a little bit towards machine learning based algorithms. And that's what we were using. We're talking out of the direction of 10 years ago, right? And what is so important in this comparison is that, yes, and I learned many things from my colleagues, data scientists, researcher, and if the technology that we have today, then I could have almost used it, right? That's the idea. So the person at our clients, at our customers, who are whatever MES manager, they're in charge of running the plant. They know the machines, they know the data, where the data is. And they, until today, use a data scientist, which maybe is not available. They have it externally, or they're in the IT department and they don't get access. So they need to wait 3 months for a special request. And now with a solution like this, like let's say a democratized version, a person who has been looking at an MES system with pressure and red and yellow and everything is green and everything 95% or whatever the numbers are that I need to know. But now I need to know one step further in the prediction, and I want to know something, and I'm going to be able to ask. Then we move into the Gen AI. I can ask a question, and then I trigger a whatever. Let's say LSTM or Tyrex based solution, and I'm seeing the answer in front of me, which is a little bit of a different discussion on the other side than as we've had it in the past. I'm looking forward to the discussion we're going to have in a couple of weeks in Berlin with what is the data scientist, and there's not enough today, but the change, I believe, of the job of that person, again, in the 10 years back, and what is that person doing today? So.
And the new job profiles are emerging, right? So in the session with Marco, we talked about the code fixer. people who people who repair, validate, and prepare AI generated code for the shop floor. So a new job profile, code fixer. Yeah.
Oh, that wasn't the session with you were in, or?
Yeah.
Yeah, there was one. So we always, at the very end, we look at plus minus, right? What do you like? We're not looking for compliments, but we're looking for more for what can we maybe do. And there was always a couple of things. And one was maybe a request for having kind of a summary of the breakout session. So what I'm going to do, and you suggested that maybe Jan Kutnik, you asked him or you told him?
It depends.
You told him that he was going to be the guy with that job. You asked him, you requested him.
Yeah.
And very nicely, Marco had already been aware of that. So he gave a summary, which I'm very happily for, bullet points here. And maybe this, what you just referred to, is included there as well. So number one, he said expectation management is crucial. AI does not deliver 100% solution. In my words, it's not yet off the shelf. Can it be? Will it be? I think so, yes. But we're just moving there. Anyway, this thought that I've had for a long time. What the difference is that we've been doing and the world is doing, we're looking at a technology which maybe in the past, I'm not sure what to compare it to. Well, let's say it's electricity, because that's what Andrew Ng and everybody else has been comparing AI to, right? And saying it's much bigger. I think when electricity was invented, that was by Tesla. Is that right?
Yes.
Or was it the other? Was it the American guy? I think there's a little bit of this, but it doesn't matter. There was a researcher. There was two researchers. There was a group of people doing tests. They were 10. At some point in time, there were 50 people. But my feeling is that as we are developing artificial intelligence, the world is part of this research community, right? It's exactly. Developing. That's a complete other thought that I have there, but there you go. So AI does not yet deliver 100% solution. You cannot yet, but I think at some point you will be able to buy a product. Human factors came out of this one as well, like time pressure, flow judgment. They often play a greater role than technical limitations. Very interesting. So I was reading it. You were a part of that session, or no, it's all of the sessions. And then staff shortages, he says. Demographics are increasing the pressure for automation, making AI projects increasingly economically relevant. Yes, I mean, that's what I've been saying all the time, not since a couple of years. Until 2-3 years back, you always had to say, oh, we're so sorry, we're coming with an automation project. And it always meant that people would lose their jobs.
And there was an interesting discussion. Let me add one point, because we talked about adding, let's say, more information from the process, from the shop floor, from the production process as model inputs, that the model better understands the context of the world, because it came up with the idea of, we talked about foundation models for sure, and then about how to generalize AI with different machines and different processes, and then was the idea, maybe we need to add something when it comes to more inputs for the model. And then we are at the point where we talk about world robotics models, right? So, and world automation models, or world welding models, or world laser models, or world injection molding models. So there was this discussion about this, and very interesting. Yeah.
Which we'll then talk about the next time, right? I guess. Yeah, and I assume it's strongly related to then, like Siemens, as an example, together with many other automation companies, looking for exactly this industrial automation model as one of the many models to provide the context, right?
Exactly. What else, Peter?
Yeah, well, and then maybe one, two thoughts of independent of the discussion you're having with Jakub in the main part. During the Jakub session, we started with, well, Jakub wrote down very base mathematical equations. I'm not going to repeat them here, but they're so base that just to share, the difference between what I believe was meant to say determinism or discriminative, and then generative, because that was the session was about. And then we did spend a lot of time around that very topic of the need for determinism, or does it mean that the AI solution can only play a part? We talked a lot about all the time about airplanes and why do airplanes have two engines? What can be done with the different solutions? So it was. It's like, and of course, it was very obvious because of being on site with SICK sensor safety solutions. That's what they're known for, right? We talked a lot about the discrepancy between the regular, the way that the international ISO standardization committees have been looking at defining safety more, let's call it a deterministic approach, and the Gen AI probabilistic approach, which is, and can we get there? Can we not get there? And maybe that's a topic actually you and I can discuss as well. Lucas Hundorf, actually, who joined us, IABG here, close to where I live, and he's very, very strongly for, and he was actually suggesting maybe one of the themes he was suggesting of the next year could be functional safety. That was a big thing that we talked about. Yeah.
Okay, maybe a quick outlook what we are planning in the next year when it comes to our events. Next stop is Amsterdam in January. We will meet Stratis and his PhD team in Amsterdam, and we will talk about their different research topics, a bit more about robotics, and then of course we will meet at AI in the Alps in summer, and then we will have a edition again in fall, but this is a long way to go, right? So first stop is Amsterdam in January.
Yeah, we have many suggestions, or many cities, many places, cities or villages. As Jan suggested, he loved being in a village, as we were at this time with SICK in Waldkirch. So there's many proposals. Robert and I will look at them, and together we will decide where we're going to be. Well, just about a year from now, I guess. It was great. Thank you for the guys who were our breakout kings, so to say. Thank you very much for our attendees, and looking forward to have you all again with us very soon.
And thanks a lot to Tim Fischer from SICK for organizing the whole stuff at the SICK Academy. Really impressive academy, very beautiful. We really enjoyed to be there. And now move to the main part with Jakub. We did a live stream on LinkedIn, and this is the audio file of the live stream. Thank you very much, Peter. It was a pleasure. And now listen to Jakub.
Yes, but I do want to just
Yeah.
a final say thank you to Barbara, who did a wonderful preparation together with you, Robert. Great preparation, such that you and I could manage locally. Thank you very much.
Thank you.
Dear listener. Thank you. Talk to you. Have you soon with us again. Bye-bye.
Bye-bye.
It's a great honor to have you with us. You landed this morning in Frankfurt. Yes. Now we are in Würzburg recording this small live stream. And we already talked the whole day about AI, the future about AI. But before we do that in the live stream, please introduce yourself briefly to the listeners.
Yes, so I work at Chan Zuckerberg Initiative. I am a senior staff research scientist there, working on generative AI for life science. And before, I was a professor and a group leader at the Eindhoven University of Technology in the Netherlands.
What is the Chan Zuckerberg Initiative doing?
Yes, so we do open science. So this is right now one of the main areas, let's say, because before there is also education and also grants for scientists, but I'm involved in the open science initiative.
And what are you doing in the moment? What fields of AI?
Yes, so we do, I would say we cover aspects like gathering data, preparing this data for further research, but also we develop our own models. So I evolve in developing own models for gene expression, some biological applications.
So it's a totally different angle of AI compared to what you did in Eindhoven and Amsterdam, right?
Yes, that's correct. Because before I worked on, for instance, medical imaging, but also general computer vision, also some text. So it was, I would say, more core AI with applications. And right now we do specific models for biology.
Can you share some of the latest and greatest by the Chan Zuckerberg Initiative when it comes to papers, to research, to models?
Yes. So, for instance, in the beginning of this year, there was this big model, and literally big because it was a large transformer.
Okay.
This was for embedding gene expression. During the summer, we also published, I was involved in this project on developing a reasoning LLM for biology. So, for instance, you can ask a question like, oh, is gene A and gene B interacting somehow?
How do you do that? A reasoning model for biology.
Yes.
Can you please some yes and details?
Yes. So this was quite interesting project because we focused on how to use reinforcement learning, how to use weak supervision for training these models. And you can find on bioRxiv our write-up on that. But in general, the main challenge was how to use this weak supervision from data. And we designed some specific reward functions such that we can enforce this result.
Do you train the LLM from scratch then?
No, we started with some publicly available models like WEM, reasoning models, and then we fine-tune them.
Okay. How long does it take to fine-tune a WEM model on your specific domain?
So, as far as I remember, it was like around 2 weeks, at least 2 weeks. And of course, we used quite a lot of GPUs.
But what is now the goal or the aim to do with these kind of LLMs, with this specialized LLMs?
Right. So this is like, we can look into like multiple directions, but one direction is, let's say we have biologists, people that not necessarily know AI, right? By default at least. And now they can maybe very quickly verify some knowledge. So like, oh, what if I knock out this gene? Will this perturb some other genes? So like these quick questions that not necessarily these generalists, general LLMs will be able to answer these questions.
But how reliable is that at the end?
Right. So this is a good question. Right now, I would say this is still like we should take these answers with a pinch of salt because after all, we fine-tune these reasoning LLMs on some specific data. If we go beyond that data, well, it's hard to say they will generalize to that.
Seb always tells us that LLMs are a database technology.
Right.
What's your opinion on that? Is it a database technology? Maybe an improved database technology?
Yeah, so I fully agree with that statement. So to me, LLMs are like, there was this very nice analogy like a few years ago, maybe already, that LLMs are like a compression of data in some efficient way, but maybe with some so-called interpolation, extrapolation, whatever it means. But after all, this is all about data and how to connect the dots. So, for instance, like if we think about the differential equations, so we know how differential equations work. They could be chaotic, whatnot, but still we can predict how they will behave. We can solve them. With LLMs, we can do that. So it is still like what was the quality of data we had to train those models. And still, because they are like a compressed version of data, so for instance, they can still make some mistakes.
Sure. But is it the way to go further in the field of LLM technology, or is it now the point to say, okay, that's the one way, and we need to think totally new about the new direction when it comes to AI?
So, like my personal opinion is that we should think about something new, but to defend a little bit, to play the devil's advocate. So I think that the idea of using tools, like with these current so-called agentic frameworks, I think this is actually quite smart. So to train LLMs to call functions, API tools, because then
But this is not a new topic, right?
this is not a new topic. Yeah.
It was invented in the early 90s.
Yes, that's correct. Yeah, that's correct. So this is not new. Maybe the new thing is that indeed we don't do it explicitly. It's very implicit because we teach these LLMs to call some functions, and then of course we start creating like this model context protocols or something similar, which is again like going in some sense away from data because this is like predefined. We need to define proper statements, explain what these tools do, etc., 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 such that everything is done using natural language and LLMs can call these tools. But again, like playing the devil's advocate, so I think this is maybe a nice way of overcoming these problems of unreliable answers from LLMs and maybe pushing LLMs to be like smart interfaces rather than...
And that's a huge topic.
Yes.
To be that LLMs will become the new interfaces at the end.
Yes, that's true. So like there are these ideas, again, not new, ideas like having like when we look at computers architectures, and so to replace the central unit with some LLM, is something that I also talked about, like how to build these generative AI systems, like exactly to put this LLM in the middle. And then this is really cool if we think about it because we don't need to define some specific logic or some different language. We use natural language. And then we use natural language to communicate, like to have natural language as a communication protocol among different subunits of a larger system.
Okay, that's interesting. So at the end, we talk about Gen AI systems then, right?
Yes.
That's your main, was your main research, or is it still yours?
Let's say after hours. This is something that I'm still very interested in. I think that there is a lot of potential that I'm super happy to see that, yes, people pay attention to these tools and how to use that. But again, like this LLM is like somewhere in the middle. This is fine. We can have different LLMs communicating with each other. But again, this is like more like small units. And also like the small language models.
Okay.
So this is also like connected.
That was my question, because I read some papers that were saying maybe we do not need the big ones for the whole Gen AI system. We need some 7B models, maybe 1B model, maybe only 500 million parameters. What is your opinion on that? Do we need this large model, big models like 70 billion, 340 billion? Is that the future?
So I'm quite skeptical about it, to be honest. I think it's very nice exercise to see what is the ceiling, and it seems that, yeah, we can take more and more. But even with current this team from Meta's Super Intelligence Labs, so we can hear some gossips maybe that, oh, actually they don't use scale AI, they use different providers because everything is about the quality of data, right? And so we can't overcome it. We can avoid having good, high quality data. If we don't have that, you can take even 1 trillion parameters, you won't train much. So I think that to me, it's more interesting to see how we can get maybe similar performance with much smaller models, because then you can start using them almost everywhere.
So when I listen to you, you are now based in the Silicon Valley. So the hottest topic in Silicon Valley is still Gen AI, agentic AI, and LLM technology. What about physics and AI?
Right. So there is also, like, next to this exact topics as you mentioned, robotics is like I see a lot of positions.
But also in the context of LLMs?
Not necessarily. Like, I think it's going beyond that. I don't see much positions, for instance, for physics and AI in general, and AI for science. there are, of course, big companies like Genentech. It's in the center of in San Francisco.
Yeah.
There are other companies like Chan Zuckerberg Initiative. We are AI for Science, but I wouldn't say that this is like it's a huge topic, but I think that still compared to how many startups and companies work on this agentic AI, I think this is like a smaller fraction.
What about data? Because a lot of companies lack on data to train bigger models, scale the models. How is the situation in the US when it comes to data?
Yes.
So they are running out of data, or am I wrong?
Yeah, this is actually a good question because on one side, I always have this feeling that, oh, we are running out of data. But then I see another version of some LLM. It actually works. It seems to work better.
But do you really see improvement?
Yeah, I think it's getting to like almost like personal opinions.
Yeah.
Like 3 months ago, like all my colleagues used Claude, or like most of them use Claude. Nowadays, they started using OpenAI again, and so I think that there are these waves. Maybe this also marketing in some sense, a psychological effects. I don't know. I think it's really hard to see. Like, it's more like a feeling rather than like today we talked about leaderboard.
Yeah, we talk a lot about leaderboards. Yeah.
And so like this is like always like closed world scenario that someone provides you some metrics and have change the metrics and hey, suddenly there's a new leader.
Yeah.
Because it's always like a chicken and the egg problem, right? So if we knew what are the best metrics, then maybe we can optimize them, but we don't know them necessarily. So it's like it's hard to say. So going back to data, I think that this is still a huge problem. Like I think that we don't have good quality data, high quality data.
For specific models or for the big ones?
I think for the big ones, because like, for instance, like we also touched upon that today, like how we human beings learn, right? So we don't train in this way that I know we are given some object and some thing, whether this is good or bad. We live right in the environment. So we touch, we make mistakes, we get some reward, and we have these proxies to some degree. We have this like people came up with this reasoning chain of thoughts and then this reasoning paths.
But is that real reasoning?
Exactly. So to me, this is not a way of reasoning, to be honest. Like it's still, I would say we still have the same paradigm that we have a closed world. We have our data, we have our trained data. We maybe train better. We have like many very smart techniques, but it's still like very static in some sense. It's not like it's like a dynamic or continuous learning.
That's the point, continuous learning. I think that's the next step, right?
Yes.
Continuous learning. If we solve this problem, then we are a step further.
That's correct. That's like I'm 100%. In my opinion, like all living organisms, as we know, I think that they get experience and they make fewer mistakes on the way. At least we are very good examples. Our pets, cats, dogs, they are all the same. And so right now we don't have these capabilities in our AI systems. Like it is still a very vivid, and there are many people working on that. Like my colleagues, for instance, in Eindhoven, they work on that. In Poland, in the UK, in Germany.
What could be an option, a way to go?
Yeah, honestly, I don't know. I think that's the first maybe way to go. The first step to go would be to abandon gradient descent and to put in place.
That's a break. Okay.
Then so this is maybe
This is controversial.
This is very controversial. Yeah, definitely. I'm not saying to use completely something different.
Yeah.
But maybe to somehow maybe put this in question.
Why?
Yeah. So I think that like we have like during we also discussed that quickly. So during
Greetings to Max Wellen.
Yes, exactly. Max Belling organized a very nice dinner during Europe's last year. And I was lucky to be invited there next to Jan de Kaan. Lenka Zdedorova, and I mentioned her because I asked Jan Lekan whether
You ask Max, right?
Max, but also Jan, and like whether gradient descent is the way to go, and Jan Lekan said that yes, there is no other option, and then Lenka said that's what right, but we know that, for instance, we don't learn by gradient descent. That is, there's no like very clear evidence. And so we should put in question training and learning algorithms. And so this is like very interesting. Maybe we should still use gradient descent, but by, I don't know, some weird optimization, like in a different way, formulating optimization algorithms, or we can maybe look at loss functions, like some, I don't know. Like when we were still, when I was still in Eindhoven, like in my group, we developed, for instance, a new learning algorithm that we phrased as a model, as a probabilistic model over training process. So it was completely different perspective, and then we show that actually this is like this Bayesian way of looking at the problem. So I think that there is still a lot to gain. There are very like beautiful papers coming up in this area.
Let's talk quickly at the end about time series. Because your opinion is, if we want to go further when it comes to AI, we need to solve the time series problem.
Yes.
What is the time series problem?
Yes. So I see this problem as like really that this AI system, let's call them, they should be aware of some consecutive like events, let's say. And so the first way to somehow solve it is to equip these models to predict also what's going to happen. So like we step in immediately into time series. So it's really something that has like some past, some future, and we can apply inference to do something with that. And why, in my opinion, is very important because
And why is it not solved from your point of view?
so it's not solved because like this is very complicated problem, because suddenly it's also training of that is not so obvious, because in this very static scenario, as I said, so it's like, okay, you have data, mini batches, repeats 2-3 weeks, 1 month, there we go. But with time series, it's like, first of all, we have fewer data typically. Second, there are some patterns, but what are the patterns? It's very hard to say. If you misspecify your window, so then it's like you don't get the patterns properly. There's also a lot of noise typically. And so we are entering into this situation that it's in some sense like getting this open world problem, because you can say that now having this time series, you are stepping into this like, oh, I don't know what's going to happen, so I have to predict and then act. So it's like getting closer to this problem of continuous learning. Of course, it is still phrased because I hear immediately voices like, hey, it's still the same problem. We have data set, we have 1 million time series, but it's but yeah, we need to formulate the problem a bit training a bit differently.
What do you mean training a bit differently?
Yeah, because like, for instance, when we think of one single time series, so now we can treat it as multiple like observations. We can treat it as one single observation. Like for instance, Tyrex. So if I remember properly, the strength of this is exactly how to treat training data. And this is important. I know that Google has that, also did something similar. So now it's getting into this situation that you can combine even inference together with training. And so we are getting into like a step closer to living in an environment that we observe, we get data, and we can, like in some sense, we can say that it's almost like exactly putting a robot baby somewhere and just getting some sensory input and trying to figure out what's going on in the world.
So the time series data is for you the key to go further when it comes to it.
Yes. Because this immediately requires also taking some actions or like at least using some inference. And it's not only like, okay, input, some output, whatever the output is, going to loss function, applying gradient. Here it's like, of course, again, the same. This is like input, some output, but now this output is structured. Or maybe this is the keyword. Like there is some structure because we know that there is some past and future. And we it's so the internal model of the world is it's more complicated than just having like some correlation or hierarchical correlation built on training data.
I see. Before we start this live stream, we had a discussion about the topic of AI.
Yes.
And how do you frame the big A on the small I, right?
Yes.
What do you mean with the big A and the small I?
So like
Leave it at the end. Yeah?
yes. So like for some time I already was thinking about it that like I think in the world of AI in research or in industrial applications, like we mix two maybe ideas like or ways of looking at AI. So I said that there's like maybe this big A and small I. So it's really like more into this artificial intelligence, small intelligence, that we have well-defined problems. We have, let's say, high quality data. We know how, we as human beings, we know how to solve a problem, but it requires a lot of, for instance, time from us, a lot of energy. And then we can, this kind of problems we can solve very well.
Yeah.
They're like more predictable. We know more or less what to do. Like, well, and it's perfectly valid. It's really perfectly valid. And then there's this second path that we have small a, but big I. So this is really like almost science fiction, right? That we really build these super intelligent systems that can do multiple or solve multiple tasks at once. And that we can like build some internal representation of the world. And for this kind of problems, we not necessarily know what are the outcomes. So for instance, like Meta Superintelligence Lab, so they try to solve that. Anthropic. Like, all these big companies that say, hey, don't work on biology because AI will come and solve the problem.
But what is your opinion? Why you still work on biology?
Yes, so I think that like I think that because of like for instance, like this continual learning could be useful for both. So continual learning could be useful for well-defined problems because then training will be much more efficient and we can literally have very smart sensors, for instance, that can rebuild their presentations on the fly. But this could be done in isolation in a lab that you train one model, you deploy, then it works. But for this small L, big I, we really need continual learning. If we want to train this 1 trillion parameters of an LLM or whatever, we really need to equip it with this capability. And I didn't see a way around it. It must be closer to training that we do as human beings. And still, I'm not 100% sure this is doable because this is in some sense, it's like with a brain. People try to reverse engineering and we still don't know how our brain works. Right? So we still have this research ongoing that discovers new neurons, new cells in our brain, and so on, so on. So why I'm interested in this biology? So for many reasons, one is that I'm fooling at least myself that I do something that is useful and maybe can help people.
Absolutely.
But also that this is, for instance, biological applications. They have this highly unstructured and unclear data and knowledge, because it's like, for instance, in physics. So you can build a simulator of physics, and it will work to some degree, better or worse. If you have GPUs nowadays, you don't need maybe AI necessarily. But in biology, it's like, we don't know why someone gets some disease and someone doesn't. Because there are so complex systems, and here AI could help us, because if AI maybe works in 75% of the cases, it's or maybe allows us to, filter the space better, like in practice numbering. So then we can speed up progress. So that's why I like these applications.